Hey guys, in this video I'm going to talk about phase changes and heat curves and how heat flows between the different phases and cause a phase change to occur. Alright, so here's a representation of all three phases, solid, liquid, and gas. And when it's a solid, it's got way less energy than when it's a liquid, and when it's a liquid, it's got way less energy than when it's gas. So when a phase change happens, when we go from a solid to a liquid, we call that melting, right? So going this way, it's called melting. And the reverse process is called freezing. Now you should already know this. I'm going to talk a lot about using water. So think about that when we talk about this stuff. So when we melt something, what's happening and what causes it to happen? A lot of students say the temperature, and while the temperature is one of the reasons, but it's not really what's happening to the molecules. So when we heat something, a solid up, to the melting point, what happens is the solid absorbs heat, and as it absorbs that heat, it turns it into kinetic energy. And so the kinetic energy increases, the potential energy increases here with the solid, and it turns it into kinetic energy when it begins to melt, because the motion of these molecules, because they're moving a lot more over here, they're kind of flowing because they have more kinetic energy. So we consider that to be an endothermic process, because endothermic means that heat is being absorbed. So when we melt something, we're absorbing heat, and the heat is being turned into kinetic energy so that the molecules can move more. And freezing would be the exact opposite of that. It would be an exothermic process, because when you put water, an ice tray, into a freezer, the water molecules lose heat to its surroundings, and so then they turn back into a solid. So exothermic means heat is released. Okay, so endo, the heat is going in. Exo, the heat is exiting. Thermothermic means heat. All right, so if you'll do me a favor and you'll put your hand on your desk or a table or maybe a piece of metal or something like that, you'll feel heat leaving your hand. That's why it feels cold to you, because heat is being absorbed by the tabletop. And so that's why it feels cold, is because you're losing heat to it. So that's the same kind of situation that's happening whenever you put water in a freezer. The heat is leaving the water molecules and causing it to just sit there and vibrate and turn into a solid. So the less that the molecules move, the closer they can get to one another. All right, so when something turns into a gas from a liquid, that process is called vaporization. And a lot of students say evaporation. Vaporization includes that. So I would rather use the term vaporization. So that's going from a liquid to a gas. And the reverse process from a gas to a liquid is called condensation. Condensation. All right. And so again, whenever it goes from a liquid to a gas, it has to absorb heat, and it turns that heat into kinetic energy so that the gas molecules can move more. And so it's going to be endothermic for vaporization and exothermic for condensation. Now, if we talk about the process of going straight from a solid to a gas, so going from here to here and skipping the liquid phase entirely, that process is called sublimation. And again, it's going to be endothermic because it needs a whole lot of energy to do that. And then sublimation, the reverse of that, is called the reverse of sublimation is called deposition. And so that process is going to then be exothermic. All right. Okay, so before we move on to the next part, I want to talk about what is necessary for something to be able to melt or freeze or vaporize or condense, the environment that it's in. Water isn't going to turn to a solid. It's not going to freeze into solid at room temperature. It's just not going to happen unless you are affecting the pressure somehow. So it has to be at a specific temperature for that to happen. And the melting point or the freezing point is going to happen at 0 degrees Celsius. The melting point and the freezing point is the exact same temperature. It just depends on whether you're putting heat in or you're taking heat out. It's going to happen at the same temperature. So it's going to melt and freeze at 0 degrees Celsius. Vaporization and condensation happens at 100 degrees Celsius. Now, of course, with gases, pressure can affect that tremendously, but the normal boiling point, so at 1 atm, it's going to be 100 degrees Celsius. So please don't think that something has to be higher than 0 degrees Celsius for it to melt. It will melt higher than 0 degrees Celsius, but it doesn't have to be there. At 0 degrees Celsius, if you could maintain that temperature and you're not adding any heat, it's just staying the same temperature, you would have slush. You would have a mixture between a solid and a liquid if it was water. Do not think that they happen at two different temperatures. They happen at the exact same temperature. Melting and freezing happen at the exact same temperature. All right, so this is a heat curve on the y-axis. Over here is usually the temperature, and on the x-axis it can be written in time, or it can also be written, you may see heat or energy added. Okay, this is a heat curve. There are also such things as cooling curves, but I generally only look at heat curves. Cooling curves, instead of starting down here at the bottom, it would start up here at the top and it would go down. So with a heat curve, let's say this is for water, and so this would be 0 degrees Celsius, and then up here, this would be 100 degrees Celsius. So if we're under 0 degrees Celsius, right here, right, this is when it hits 0 right here. So we're under 0 degrees Celsius, and that's the freezing point. So if we're under the freezing point, that means that it's going to be a solid. So from A to B, it's going to be a solid. And so we keep adding heat to it. We keep adding heat to it until we get to here. And as we're adding heat, because this is going up, that means the temperature is increasing. So the temperature of the solid is increasing. And once we get to right here, it begins to melt because it's reached its melting point. And so right here it's melting, but the temperature is not changing, and that's how we know it's melting, because it's going to stay the same temperature until all of it, all the substance that we have, has melted. And so this process right here is melting. Oops. And if we were removing heat, right, we started up here, we remove heat, we'd go this way, and so it would be freezing. And so that's why the temperature is the same for melting and freezing. All right, and so while it's melting, we would have solid and liquid both present in the container. Now, if we continue to add heat, so we're continuing to go across here, we're continuing to add heat, now we're just heating up liquid. And so we just have liquid present right here, and we just keep heating up the liquid. Right? And then all of a sudden we get to 100 degrees Celsius, and at 100 degrees Celsius the temperature all of a sudden starts to stay constant again. And when that happens, we know we have reached another phase change, and that phase change is going to be vaporization. And so when something is vaporizing, during that process we would have liquid present and gas present, and the temperature would stay the same until all the liquid has turned into a gas. And once all the liquid has turned into a gas, then now we're just adding heat to a gas, and so the temperature of the gas is just getting warmer. And so this would be a gas down here. So now if we talk about kinetic energy and potential energy, I need to remind you what kinetic energy is, or actually what temperature is. So temperature is a measurement of the amount of kinetic energy. So if the temperature is changing, then that means the kinetic energy is changing. So the kinetic energy is changing the most during these phases right here. So kinetic energy changes here, and the kinetic energy also changes right here. Whoa, what is that? What? All right, I fixed whatever that was. It's probably going to happen again. And then the kinetic energy also changes right here where it's a gas, because the temperature is changing, right? The temperature is not changing right here or right here. All right, so I fixed that. Okay, sorry about that. The potential energy is going to change up here. Because the energy is changing, right? But it's storing the energy because the temperature isn't changing because of it. So it's storing the energy right here, and so the potential energy is going to change when it melts. And I think I got that wrong in class because it's been a while since I've taught this. This is usually the unit that I have y'all teach yourself. It's really no excuse, but it's the truth. So make sure that you get that right, all right? Let's see, paste. So it's going to change right here too. See if I got everything. Oops, forgot that. There we go. Okay, so just to review, down here is where it's a solid, right here is where it's a liquid, up here is where it's a gas. This is the process of melting because you're going from a solid to a liquid. So if it melts, it's going to be through this part BC. If it vaporizes, it's going to be through the part DE. If it condenses, it's going to be, condensation is when it goes from a gas to a liquid, so it's going to be this part right here. It's just the reverse of it. If it freezes, it's going to be between liquid and gas, or liquid and solid, because it's going from a liquid to a solid, so it's going to be this part right here. Kinetic energy changes when the temperature is changing, and potential energy changes when the temperature is staying constant. So it's going to be during phase changes. And that's pretty much it. So if you have any questions, let me know. Otherwise, that's the end.